Okay, so we are looking at 7.1, and 7.1 is about sets. Let's start off by just defining a set. A set is a well-defined collection of objects, and the objects in a set are called elements or members. A notation is with braces. So an example, we can say that these are braces, and we have these numbers in the inside. All right, we can say that this is a set. Once again, the braces is the notation, right, for a set. We can say this is a set with elements 2, 4, and 5. Because once again, it says that a set is a well-defined collection of objects. So a set has objects, right? So the braces tells us that it's a set, right? And we see that we have 2, 4, 5. The objects in the set are called elements, right? So once again, braces imply set. Everything in the inside will be called elements or members. So let's take a look at some notations, some additional set notations. What we see in this set, right, we see that once again, this set has elements 2, 4, 5. So we can say that 2 is an element of this set. But instead of using these words, we'll show this symbol. It looks like a C with this line in the middle. Right? So this reads 2 is an element of 2, 4, 5. We can see 2 is clearly in there. What about 3? We can say that 3 is not an element of our set 2, 4, 5. So how do we show this? Kind of like the same way, we have this C and we have this line in the middle, but now we put a slash through it. Right? So this is reading 3 is not an element of 2, 4, 5. Another important property of sets is an empty set. Right? So an empty set is a set that contains no elements. And the notation is just, we can see here, braces once again has a set, and we can see in the inside there's nothing in it. So that is a notation for empty set, or a circle with a slash through it. So, what we can say is 5 is not an element of this empty set, right? 5 is not in there. Also, we can say 5 is not an element of that empty set, right? But what about this example? Is this true or false? Well, let's take a look back here. Once again, we looked at is an element. We can clearly say that 2 is an element because we found it in there, right? Right here we can say 3 is not an element because where in the world is 3? It's not in there, right? So we take a look at this example. This would definitely be a true statement here because we can see that this empty set is in there. So a very nice example, taking a look at these empty sets and sets. Now let's talk about subsets. Right, so what we can say here is we can say that set A is a subset of set B if every element in set A is also an element of set B. So, and our notation looks like this. Right, and this reads is a subset of, right? Is a subset of is that. So example, let's just say we have this set that has elements A, B, C. We have this set that has elements A, B, C, and D. We can clearly see that all the elements in our first set are found in our second, right? We can see that A is there, B is there, and C is there, right? So what we can say is that this first set is a subset of our second set. But what if we looked at it the other way? What if I wrote A, B, C, D first and wrote A, B, C second? Can we still put this subset notation? Well, we see A is there. We see B is there. We see C. But D is not there. So here, this first set is not a subset. Is not a subset of A, B, C. And this also has a special notation, right? It looks like our subset notation, but then we put a slash through it. And now this ends up being a true statement. So some nice examples of some set notations, right? We looked at element of, right? We take a look at this notation, not an element of. We also looked at an empty set. And we looked at subset and not a subset.